Hi everyone, how are you all? Yeah, so in this class, I would like to explain one of the important chapter in the physics, that is the vectors. So to understand the kinematics 2D, that is the motion in two dimensional. So we have to understand the vector concept. So today I am going to explain here the vectors. So in this class here I am going to discuss the types of physical quantities. Then after we discussing the types of the physical quantities. Then we are discussing the types of vectors. Okay. So already we have discussed that here in case of units and dimensions. So we have some classification in the physical quantities. What are the classification of physical quantities? This is fundamental physical quantities. So fundamental physical quantities, fundamental physical quantities, fundamental physical quantities. Next, supplementary physical quantities, supplementary physical quantities. Next, derived physical quantities, derived physical quantities. So this is one classification. One more classification in the physical quantities. So they are first one is the scalar physical quantities, scalar physical quantities, scalar physical quantities, physical quantities, and one more classification that is called as a vector classification. So vector classification, vector physical classification. Okay. And our chapter is concerned the vectors here, and you know that here the previous knowledge of subject here. What is a scalar? Scalar, the scalar physical quantities. What is the scalar physical quantity? The scalar physical quantity, it has only magnitude. It has only magnitude. So what do you mean by magnitude? Magnitude is nothing but the quantity how much it is. For example, if we say so 5 kg, so 5 kg, so 5 kg, so any number with its unit is called as the magnitude. For example, if you write like that 3 meters of length, and meter is unit of length here, and meter is numerical value. How much? How many times that unit here? That is 3 meters. 3 meters is the magnitude. This is the magnitude of the length here. So these are all called as scalar physical quantity, and also it obeys the simple algebra. It obeys simple algebra. Simple algebra. So what do you mean by simple algebra? Like for example, 3 plus 3. For example, 3 meters and 4 meters. That is equal to 7 meters. So it will follow simple algebra operations. And 7 minus 3, 7 minus 3, like that. There are always very simple algebra condition. So okay. So we don't consider the direction in case of scalar physical quantities. It has only magnitude, and also one more rule here. Simple algebra. It follows simple algebra. So the quantities which follow these 2 points here, that is called as scalar physical quantities. So one more thing is there, and next classification of physical quantity, that is a vector physical quantity. Vector physical quantities. So what is the vector physical quantity? So vector physical quantity has both magnitude and direction. Has both magnitude and direction. Magnitude and direction. Magnitude and direction. And also which follows the vector law of addition. So which obeys vector law of addition. Vector law of addition. Vector law of additions. So it has both magnitude and direction. Means here, for example, so if you take one example here, for example, your mom ask you that ask that to buy the sugar from our shop. How can you ask the shopkeeper to buy sugar here? Please give me 5 kg of sugar. Please give me 5 kg of sugar. So it is a complete information to buy sugar here. Therefore, the shopkeeper understand the information, and he will give you the 5 kg of sugar. Okay, it is only magnitude. That's why it is a scalar quantity. But here one more example I will give you, that is the position. So in case of position here, in case of position, it means here there is a person. There is a person who is standing here, standing here. Now he is the person. He asking the other person, can you find my bike location, which is 2 meters from me? So 2 meters. So it is a incomplete information, because here to find the bike location, so we need one more information, that is called direction. So you should go direction. You should go in the north direction with a distance of 2 meters. Then only you can find out the your bike location. Your bike location. So that's why position is a vector quantity. Okay. So in our nature here, we have so many physical quantities are available, so many vector quantities are available. They are called as a displacement, 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 and force, force, force. Next, acceleration, force, acceleration, force, acceleration. So many physical, so many vector quantities are existing in our nature. Okay. So our chapter is comes under, this is physical quantities which are existing in our nature, and now we are going to discuss the chapter. That chapter is vectors. So our chapter name is that vectors. Vectors means we are going to discuss about the vector physical quantities which are having the both the magnitude and direction, and also it obeys the vector law of addition. So we will discuss. So in the case of vector law of addition, we don't add directly 3 plus 4 and like that. So which has direction. Because of direction only, so we don't add that type of the quantities. So definitely, so we follow some vector law of addition, and we will discuss all these rules in the coming classes. Okay, but you should know, so there are two rules which are followed by the vectors. Okay, so this is the vector, so exact direction, and this is physical code vectors, and this vector representation. So representation of the vector. Next one is representation of vector. Representation of vector. Representation of vectors. Representation of vectors. So I change my color here because it's not visible here. So representation of vectors. So the graphical representation. First one is the graphical representation. Graphical representation. Graphical representation. Graphical representation of a vector. So generally we can represent here. It is a line which is having arrow. So here we know, just I have explained earlier. So it has magnitude. Magnitude is always indicate the length of this line. So the length of this line indicate the magnitude. So the length of this is the magnitude. For example, it is 2 meters like that. 2 meters is the magnitude of this vector. And this arrow indicate the direction. This arrow indicate the direction of the given vector. So these vectors are having the starting point. The starting point is called as the tail of the vector, and this point, the head, this is called as the head here. The head point is called as the final position of the vector. Final position, final header, final position of the vector. So this is the representation, graphical representation of the vector. So the length of this vector is called as the magnitude, and this arrow indicate the directions. Okay, in this way we can represent any vector. If it is, for example, if we take two vectors here, so this is my vector A bar, this is my vector A bar, and this is my vector B bar. So which is having the less magnitude? So B bar has less magnitude compared to the A bar. Okay, what is the direction of the A bar and B bar? Both are in same direction, because the arrow of first vector, this A bar vector, and the arrow of the second vector, which are in same direction. That's why we can say that they are having the same direction but different in magnitude. Because of, if you see the length, if you measure the length here, so the length of the A bar vector is greater than, so A bar vector, the length of A bar vector, so length of A bar vector length of a bar vector is greater than so length of a bar vector is greater than the length of B bar vector, length of B bar vector. Okay, now so this is the way we can represent the vector in graphical representation. Next here, mathematical form. So now we can represent the vector in terms of mathematical representation. Mathematical representation. Mathematical representation. Mathematical representation. Mathematical representation. So now we can represent any vector in terms of mathematical. So for example, if we take a vector that is A is a letter, alphabet letter, and take the arrow at the top of the vector, this is called as the representation of the vector. Okay, representation of the vector. And also, so we can represent magnitude of this because we know that here vector has magnitude. So we can represent magnitude is like that, the modulus. So modulus of this a bar, two lines indicate the magnitude of a bar vector, and multiply with the direction of the a vector. Direction of the vector always is given by a unit vector, that is a cap. So we'll discuss later that is a cap here. So this is a representation of the a vector in a mathematical form. So this is modulus. Modulus means here magnitude, which gives the magnitude of the a bar vector, and a cap, which gives the direction of the a bar vectors. Okay, and a unit vector a cap. This is a cap. We will discuss in the next coming classes here. What is unit vector? I will explain whenever the vectors are coming, and I will explain unit vector. Okay. So first we have to know how to represent the vector in a mathematical form. So a bar is equal to magnitude of vector, that is a bar, and also direction of the vector, which is given by unit vector. So this gives the direction of the a bar vector. For example, if we take a b bar vector, so how to represent the vector in mathematical form? So first write the magnitude of b bar vector, and also direction of that b vector, which is given by unit vector. So b bar is equal to magnitude of b bar vector. So generally in other textbooks they are giving like that so modulus of b bar, which is also given the b. So b is whenever we write only b, don't write any arrow. This gives the magnitude. So magnitude means it's a scalar. So magnitude means it is a scalar quantity. Okay, this is a mathematical representation of any vector. Now go for the types of vectors. We have, after knowing the definition of the vector, now we are going to discuss the types of vectors. Yeah, first one here. So in that one, the first one is that here, unlike vectors. First vector type of vector, unlike vectors. So in this unlike vectors, so the vectors which are having the same direction. This is my vector, and the vector name is a bar vector, and another vector that is the b vector. Okay, so we are not taking consideration of magnitude here, because if you see two vectors here, the magnitude of the a bar vector is greater than the magnitude of b bar vector. And what is unlike vectors means here, the direction of the both vector which are in same direction. So direction is same. So direction of the both vectors. So direction of both vectors are same. Direction of both vectors are same. Therefore, we can say that the both vectors are called as the unlike vectors. Whatever the magnitude, but so the condition is that the direction of the both vectors should be in the same direction. That is the unlike vectors. Sorry, here it's not unlike vector, it is a like vectors. Okay, like vectors. Like vectors means here they are in the same direction. But with different magnitude. Next here, second one is here, unlike vectors. Unlike vectors. Unlike vectors means here their direction is different. So the direction of both vectors are same. So this is my vector a bar vector in this direction, and one more vector, this is a b vector, and the direction of the both vectors are different. Okay, so this type of vectors are called as a unlike vector. So direction of both vectors are not same. Direction of both vectors are opposite to each other, or opposite to each other, opposite to each other, opposite to each other. Right. Next one here. That means they are mutually opposite. They are mutually opposite to each other. Therefore, we can say that these two vectors are called as unlike vectors. Unlike vectors. Next here, equal vectors. Equal vectors. Equal vectors. Okay. Next here, equal vectors means here the vectors which are having a same direction and same magnitude. Okay, and this is the a vector and this is the b vector. Both are having the same magnitude. The length of a bar, length of b vector, both are same and direction also same. Therefore, we can say that these two vectors are called as equal vectors. Equal vectors. The vectors having same magnitude. The vectors having same magnitude, and same direction. Same magnitude and same magnitude and same direction. Same magnitude and same direction. So therefore we can say that both vectors are equal vectors. Okay. Next here. Next vector type is co-initial vectors. Co-initial vectors. Co-initial vectors. So initial means here starting point. The vectors having same starting point, the same initial point. So we can say that the vectors are called as the co-initial vector. For example, this is the a vector, and this is the b vector, this is the c vector, this is the d vector. So a vector having starting point which is called as O, b also starting from O, c also starting from O, and D also starting from O. Therefore, we can say that A bar and B bar and C bar, A vector, B vector, C vector, and D vector are called as the co-initial vectors. Co-initial vectors. Co-initial vectors. Co-initial vectors. Okay. Next one. Next one, co-terminal. So this is the like vectors generation. Okay. Next, go for the and co-initial vectors. Co-terminal. Co-initial is over. The vectors which have same initial point are called as the co-initial vectors. So this is vector. So this is my point here, starting point for the A vector, and this is starting point for the B vector. This is starting point for the C vector. Therefore, we can say that the A vector, B vector, C vector are called as the co-initial vector. For the co-initial vectors, starting point is same. Okay. Next here. And fourth one, co-terminal vectors. Terminal means ending point. The vectors which are having the same ending point. So therefore, the vectors are called as the co-terminal vectors. For example, the vectors which have same terminal point, are called as the co-terminal vectors. So see here, A vector and B vector and C vector, they are ending at this point. This is the letter, suppose you can say O point. So A bar vector and B vector, C vector are co-terminal vectors because they end at one point. Okay. Yeah. Next one. Next here. Next vector, collinear vectors. Collinear vectors. Linear means here line, straight line. Okay. So the vectors which are parallel to straight line or which are lie on the same line, that vectors are called as the collinear vectors. So take one more color here to represent the collinear vectors. This is my vector, and I can take this is the AB, and AC, and AD. So AB vector and AC vector and AD vector all are in the same line. That's why they are called as collinear vectors. Collinear vector parallel to straight line. Parallel to straight line are called as a collinear vectors. So AB and BC and AC. So they are called as collinear vectors. Okay. So the collinear means here. So the vector which are lying in the same line and also they are parallel to each other. The vectors which are parallel to each other they are called as a straight line. Parallel to straight line. So are called as a collinear vectors. Next one. Next here coplanar. What is the coplanar means here? The vectors lie in the same plane. For example, if you take here, this is my x coordinate, x axis, and this is my y axis, and this is my z axis. Okay, and two vectors which are lying in the xy plane. Therefore, we can say that these a bar and b bar vectors are called as coplanar vectors. For example, if you take one more vector in the YZ plane, this is the YZ plane, this is the XY plane, this is the XZ plane. Okay, so this is in different plane. Therefore, A C vector and B vector or C vector and B vector lie in the different planes. Where C vector and B bar are called as non-coplanar vectors, or C vector and A vector are called as non-coplanar vectors. Okay, so this is a bar. Here, example A vector, B vector, coplanar vectors, and also and A bar, A vector, and A vector, B vector, and C bars also in coplanar vectors. Okay, right. So next here negative vectors. So negative vectors means here, for example, so there is a vector is there which is having the is having magnitude is this much length here, and negative vector of this vector is just change the direction, and don't change the magnitude. So this is a minus a bar. Okay, negative vector of a bar is minus a bar, just change the direction. Minus indicates the direction of that vector, that is called as a negative vector. So two vectors are said to be mutually negative vectors. If their magnitudes are equal, direction mutually opposite. So the magnitude of the both vectors are same, and direction mutually opposite to each other. Therefore, we can say that the two vectors are called as a negative vectors. So what is the negative vector of p bar? That is this is minus p bar. Okay, so this is about the negative vector. So this is a p bar vector. Negative p bar is here. This is q bar. This q bar is equal to minus p bar. Okay, right. Next here, equal vectors already just we have discussed here. They are having the same magnitude and same direction. Okay, next one. Next here, null vector. So what is null vector? The magnitude of the vector, magnitude of that vector is 0. That is magnitude of that vector 0 means it's point. So point. So the length, there is no length for the vector. That is called as a null vector. Okay. So the magnitude of null vector is 0. So the direction of this vector we cannot define. It is a indeterminate. Okay. So these null vector can exist. Okay. It is existing in the nature. It means, for example, a bar vector is there. What negative vector of a bar minus a bar? If you add it here, definitely we get a null vector. Okay, so this is about the null vector. So anyone ask you like that, null vector means here the magnitude of this vector is 0. Therefore, we can say that the magnitude of null vector is 0. Then that vector is called as a 0 vector, null vector. Okay, next here proper vector. So what is the proper vector? A vector whose magnitude is not equal to 0. Okay, if it is null 0 means here magnitude is 0 other than 0. So a vector whose magnitude is not equal to 0, that vector is called as a proper vector. It has a proper magnitude and proper direction. That is called as a proper vector. So this is a proper vector. This is also a proper vector because it has some magnitude and some direction. Okay, next one, the position vector. What is the position vector? Position vector means, for example, if we take a Cartesian coordinate system, x coordinate and y coordinate here. Okay, so any vector which originates from center point, that is originates at the origin and terminates at any point in the Cartesian coordinate system. This is the Cartesian coordinate system, any vector, but starting from origin. So this is also position vector, and this is also position vector, and this is also my position vector. So length of this vector is this much, and direction is this much here. So ending, so it terminates at any point in the coordinate system, but so it starts at the origin. It starts at the origin. Therefore, this is called as the position vector. Okay. Next here, last one in this video, that is unit vector. This is very important here. So unit vector. What is unit vector? What is unit vector? So unit vector is a vector whose magnitude is 1. So magnitude of unit vector is 1. So magnitude of unit vector is magnitude of unit vector is 1. Okay. And what is the specific significance of this unit vector? The significance of unit vector and this magnitude of unit vector, and it can be, the vector can be represented by a cap or hat. Some textbooks they have given cat, some textbooks given hat. Okay, and both are same, hat or cat. Okay, and these unit vector also give the direction of the and given vector. For example, this is a bar is there, and so the direction of this vector which is given by a unit vector, unit vector. Okay, yes, listen, and to understand unit vector I will take that is one of the example here. That is example is here. This is the length of the a bar vector. I divide its length into some equal parts here, each equal part length is here 1 unit and 1 unit and 1 unit and 1 unit. Okay, 1 2 3 4 5 6 and 7 and 8 units. Okay, therefore I can take length. So here, so the my physical quantity in that example is length is equal to is 7 meters. So length means magnitude. This is the magnitude. So 7 is a number and m is a unit here. Okay, this is a number I can take and multiple. Okay, so these are n times 7 times of given unit. So this is unit of length here, 7 times of that unit, that is called as a length here. So n into that unit, so n multiples of that unit here. Okay, and n times 7 times of the unit which gives the physical quantity. In the same way, if we take a unit vector, this is a length, the place of length, you can take a vector, given vector, and n into that is unit vector. This is a unit vector. So in this case here, the nature of the vector and direction of this unit vector both are same. Okay, the direction of the and vector, direction of the unit both are in same direction, like that. So this is a unit value which is in this direction. This is a full vector which is in same direction. So direction of this vector. So the direction of the this full vector which is given by this unit vector. Okay, because of the magnitude of this vector is here only 1. If you multiply this 1 with that number, we get there is no change of that value here. Okay, so in this case, from this case here, so I can write a vector. So vector is equal to n times of that unit vector. Okay, so in this example I can take a vector, a bar is my vector, and n is called as n times n multiples. That means it is a magnitude or number. So it is magnitude. Already you know that magnitude of that vector is here. So magnitude of a bar, and unit vector a bar is a cap. So from this here we can write here a cap is equal to, so a bar by magnitude of a bar. So in this way we can find out the unit vector of any vector. So how to find out the unit vector of a vector? So take the full vector, a bar vector, and divided by the magnitude of that vector. We get the unit vector of given vector. So actually generally we can say that unit vector is a part of the full vector. A unit vector is a part of the full vector. The magnitude of this unit vector is 1, and the main significance of the unit vector is that which gives the direction of the given vector, which gives the direction of the given vector. This is a important. This is a topic. So with this topic here we conclude. and next video, so we discuss remaining topics. And I hope that you understood my lesson here. If you understand my lesson, please like and share and subscribe. Thank you very much.